Hello everybody, Adam Lusek here, and today I'm going to show you all how to make engaging and exciting YouTube video scripts using audio and language models. The sort of high level of how this is going to work is it's going to first take a YouTube video and extract the audio from it. Taking that audio file, we're going to run it through OpenAI's Whisper 1 audio to text model so that it can generate a very robust transcript including all the different language nuances and punctuation. Using all of that, we're then going to run it through an analysis in GPT-4 Turbo so that it'll look at sort of all of the different parts of the script and pick out what's making it engaging, what is making it exciting, and how can someone sort of replicate it. And then the final step will be taking the actual transcript and the analysis and then applying it to a new topic and having the language model generate a script on this new topic using the different techniques that we saw in the analysis and the actual script itself. So to look a little bit about how the code is actually operating here and what we're using. For converting the YouTube video to an audio file, I'm using PyTube and MoviePy. All of my artificial intelligence plugins is just the OpenAI regular package and then LangChain here. I'm going to be using the docx package to sort of put everything back into a nice Word document so that it's easily readable. Don't have to be looking at this Jupyter notebook all the time. And then, of course, I've got some regular expression stuff, some time stuff, and some operating system stuff just for some file manipulation, timekeeping, and filtering down. Setting up everything for the APIs and instantiating that all was pretty easy. For some reason, FFmpeg isn't recognized on my computer when I'm trying to use like MoviePy and PyTube to convert these MP4s to MP3 files. So I had to install it via Homebrew and make an explicit environment path to it. OpenAI, of course, had to get their AI key from the environment variable, and then I just instantiated OpenAI using their simple function here. These are just timekeeping variables or timekeeping functions so that when I'm actually running the program, I can show you all how long it took. Then to get the actual video audio, I did this into two parts. I first wanted to just have the video ID so that I could easily name things and then easily path to them. And I used a bit of regular expression filtering down here to grab that based on a URL link input. And this is pretty easy. YouTube doesn't make this too complicated because if we actually look at a YouTube video, it turns out that this last part of the YouTube video is actually the video ID itself. This is super useful when using things like the Google YouTube Data API, where you can pull all sorts of different statistics and different metrics from the actual video ID input. But I just wanted it for ease of naming and ease of sort of navigation. Downloading the MP3 file is then the only time that I'm actually really using MoviePy and PyTube. I create a PyTube object from the direct URL input of the YouTube video, and then I do a little bit of filtering down to just get the audio file. Here, I also check if it's just an MP4 file. If it's not an MP4 file, I convert it to MP3 using this audio file clip function, and then write it back out to an MP3 file, removing the old MP4 file. So this basically takes, these two functions will take the video, create a video ID, and then download the audio and convert it to an MP3 file, which is what Whisper 1 will be taking as our input. And so then once we have the audio file downloaded as an MP3, what we then want to do is extract the transcript from it, which is where the first model comes into play. Whisper 1, OpenAI's audio to text model. So I have this function defined here, which is pretty simple, where all it does is it opens the audio file using the project destination path and the video ID that we defined earlier, and runs it through this quick function with the OpenAI API. OpenAI makes it pretty damn easy to create these transcripts. It's just openai.audio.transcriptions.create, and then you explicitly define the model. Right here, I'm using Whisper 1, and then the file that you want to pass through, which is, of course, this file that I defined here. That creates a transcript object of which you can grab the text from it, and then I have it return the transcript text here. And so now that we have the transcript as a nice, just plain text string, what we can do is then pass it through a couple prompts to do exactly what we want. The first one that I put it through is this transcript analysis prompt. So let's read this and discuss it a little bit. I put down that you are an advanced assistant that analyzes the transcripts of YouTube videos to provide analysis on them. You diligently review each part of the script and the many different ways it is formatted, including elements like sentence structure, word choice, syntax, the flow of the transcript, how it is structured, how it is delivered, and anything else that could help someone looking to imitate its style create something similarly engaging, adding or removing depending on how important the concept is to the analysis. That's the main bulk of it. And then just for the output explicitly defining that, I put you will provide a detailed yet concise analysis of the transcript with things like actionable and notable takeaways. Format this as short paragraphs with line breaks, including examples where necessary, and stray away from using lists unless very useful. Make your response 200 to 300 words. And then I have the provided transcript is here, and then in brackets, I will explicitly pass through the transcript. The actual content creation prompt then that I have is you are the best YouTube video transcript generator ever created, accurately and effectively following given script examples and analysis to generate engaging, unique, and naturally flowing YouTube video transcripts. You will take an example script and an analysis of the script and generate a new script, taking inspiration from the ideas generated in the analysis and the transcript itself to create an engaging video script on a new given topic. Your output is just the script itself, similar in length to the original script input in. And then here in brackets again, I have explicitly defined script, analysis, and topic, which I will pass through. Setting up all the LangChain stuff is pretty straightforward. The output parser that I'm using is just the string output parser, so it'll take all of the output from the language model and convert it to a string. This right here is just setting up the language model. I'm using chat OpenAI from LangChain with the temperature set to 0 and the model being GPT-4 Turbo. These two lines right here is just taking these prompts that we explicitly wrote down here and converting it to the right template using the chat prompt template from template function. And then here I'm using a little bit of LangChain common expression language. It's always a hard one to say to actually define the chains. I'm using runnable pass-throughs so that I can easily input all of the stuff that we need into these bracketed sections here of the prompts. So for the analysis chain, I only need to define that the transcript is going to be a runnable pass-through, pop in the transcript prompt, the model, and then the output parser being the string output parser to create the chain. The content creation chain, using this content creation prompt, it's a little bit longer, but all it is just taking the script, the analysis, and the topic, explicitly defining them as runnable pass-throughs, and then also having the prompt, the model, and the string output parser. That's most of the main code. The rest of it is just taking all of these variables and popping it into a Word document. That's not really relevant for this project, so let's take a look a little bit at what this main script is actually. First is just defining the destination that I want it to be in, followed by two inputs that I have here. Inputting the URL link of the YouTube video, and then inputting the new topic that you want the new script to be generated by. I start my timer, which we will see in action shortly, and then run through a few of these aforementioned functions that we defined. The first being the video ID, where it'll extract the video ID from the URL, and then using all of that plus the URL and the project destination, we'll convert that video into an MP3 file. Here is where we are invoking sort of the different models. The actual transcript is going to be using the getTranscript function, which will be taking advantage of OpenAI's Whisper 1 model, followed then by the analysis chain, which we will invoke here with the transcript. The creation of the next video script takes a little bit extra. We need the different inputs in a dictionary format, with the script being the transcript, the analysis being the analysis here, and then the new topic being the topic here. This will then all be nicely formatted with the runnable pass-throughs that we defined in the chains before. And then, of course, using that all, we invoke the chain with the inputs to create the video script. I then pass all of that into my build report function, which just takes all of those variables and formats it quickly into a Word document, thus finally printing out the runtime. So let's take a look at what we actually want to use this for and see it in action. And first off, of course, we need to choose a YouTube video. And this is going to be a live demonstration, so I haven't used this YouTube video, analyzed it at all, or run it through to try and create a similar script at all either. And this is a video from David Bombal, who is talking about fiber optics cables. And to just play a short clip from it,
or watch other videos on the internet. This is a fiber optic cable. Here are two versions, single mode, multi-mode. What's the difference?
We won't play too much of that, as you should check out his content that he makes himself and support him, of course. But basically, it's very informative, very clearly delivered, and I'm no YouTube expert, so I would love to sort of see what I can learn from the way that he talks in his videos and see how I can apply it to something different. So, hopping back over into the main script in this Jupyter notebook, we're going to input in the YouTube video. And then the new script I actually want to be about audio interfaces, what they do, how they work, and why they are useful in comparison to built-in audio software on your computer. If you can't tell, I'm using one right now with this microphone, so that's top of mind. And so let's enter that in, and then it'll run. And so I'm going to let this run and then be right back. But you can see already that like MoviePy is converting this to an MP3. Sweet, so that's all finished up. Took about 86.64 seconds, it's saying, to do all of the transcript generation, and then downloading all the MP3s and converting it all and running all the analyses and creating the document. So let's take a look at the actual document created. So here it breaks it down into three parts: the transcript, the analysis, and then the new transcript. And then I also just have a little bit of details in here so that we can easily reference the topic that we input and the URL of the actual YouTube video that we were looking at. This transcript is the output that was generated by Whisper 1, the audio to text model. And what I really like about Whisper 1 is that it's able to pick up on sort of different punctuation, different nuanced things like questions being asked, where things like plugging directly into YouTube's data API and pulling out the closed captioning isn't so good at. But this transcript, I feel, pretty accurate, gets it all nice and down there. But let's check out what it actually had to say about it in this analysis. So it's saying that transcript opens with a very direct question to the viewer. Do you know what this is? This approach immediately engages the audience by prompting curiosity and participation. The speaker then quickly connects the topic to the viewer's current activity, watching the video, which personalizes the content and increases relevance. This technique of linking the subject matter directly to the viewer's experience is effective in retaining attention. That's actually a pretty good point. I didn't even think about that. Explanation of fiber optic cables is structured in a way that balances technical information with accessibility. The speaker introduces two types of fiber optic cables, single mode and multi-mode, and uses a visual demonstration to explain the difference. This method of showing rather than just telling is crucial for topics that involve physical or technical components. The use of a light to demonstrate how signals traverse through the cables serves as a practical example that is both informative and engaging. The language used is straightforward and avoids unnecessary jargon, making the content accessible to viewers who may not have a technical background. However, when technical terms are used, such as single mode and multi-mode, they are immediately explained in a simple manner. This ensures that the content is inclusive and educational for a broad audience. The transcript also effectively uses comparison to highlight the differences between single mode and multi-mode fibers, such as the distance the signal can travel and the cost. This comparative analysis helps viewers understand the practical implications of each type of cable in real-world applications. One notable takeaway for someone looking to imitate the style is the importance of directly engaging the audience with questions and relating the content to their experiences. Additionally, the use of visual demonstrations and comparisons can significantly enhance the clarity and engagement of technical explanations. This is sort of tailoring off into some general stuff, but I think it actually was able to pick up on some pretty keen things. Things like starting with a question, connecting it to the current activity, such as watching the video, the different ways that the explanations are structured with using both of the two different types of cables and then visually demonstrating it. Language used being very straightforward. It picked up that when technical terms like single mode and multi-mode are used, they're immediately explained, and then also some stuff here. So I think this analysis is actually pretty solid, given that. So what then did it come up with for my topic of audio interfaces, what they do, how they work, and why they are useful in comparison to built-in audio software on your computer, using this transcript and using the analysis? Let's check that out. So it looks like in this new transcript, it actually put together a whole, play-by-play thing with opening scenes, different shots of what I should do, different segments and demonstrations, but it's saying unlocking superior sound, a magic of audio interfaces. And let me put on my best YouTuber voice and try and read this out. Opening scene. Host. Ever wondered why your recordings or streams don't sound as crisp as the pros? Or why your virtual instruments lag behind your creativity? You might be missing a crucial piece of the puzzle. Do you know what this is? Cuts to a shot of various audio interfaces. This, my friends, is an audio interface. There's a good chance you're not using one right now, but you definitely should be, especially if you're serious about your audio quality. Today, we're diving into what audio interfaces do, how they work, and why they're a game changer compared to the built-in audio on your computer. Cue segment 1. What is an audio interface? At its core, an audio interface is a bridge. It connects your microphone, instruments, and other audio sources to your computer, allowing you to record and play back with superior quality. But not all interfaces are created equal. There are two main types that you'll encounter, USB and Thunderbolt. Cue the visual demonstration. Let's plug a guitar into both types and see what happens. Notice how the sound is clearer and more vibrant through the audio interface? That's because these devices are designed to handle high quality audio without compromise. Cue segment 2. How do they work? Audio interfaces work by converting analog signals from your instruments or mics into digital data that your computer can understand, and vice versa. This process is called ADDA conversion. The quality of this conversion is what sets apart good interfaces from the great ones. Cuts to a visual explanation of ADDA conversion. Moreover, audio interfaces come with preamps, which boost the signal from your microphone to a level where the rest of your gear can work with it effectively. This is crucial for capturing the nuances of your video, of your voice, or instrument. Cue segment 3. Why use an audio interface? You might be thinking, but my computer already records audio. Why do I need an extra piece of equipment? Great question. Built-in audio often lacks the necessary components to handle high-quality, low-latency latency audio. This can result in noise, delay, and an overall lackluster sound. Cue the comparison. Built-in audio versus audio interface. Let's do a quick test. Here's a recording using the built-in audio of a computer, and here's one using an audio interface. Play samples back to back. Hear the difference? The interface provides a clear, more professional sound. Plus, with an interface, you can record multiple sources at once, control levels more precisely, and monitor your audio with zero latency. Closing scene. In the world of digital audio, an audio interface is indispensable. Whether you're podcasting, streaming, producing music, or just want your Zoom calls to sound better, an audio interface can elevate your audio game significantly. Cuts back to host. So, are you ready to take your audio to the next level? Dive into the world of audio interfaces and unlock the true potential of your sound. Until next time, keep creating, keep experimenting, and keep sharing your voice with the world. End screen. And then a little thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe for more tech tips and tricks. Got questions or want to see a specific audio interface reviewed? Drop a comment below. Video ends. So this is actually, I feel pretty decent. I took a lot of what it was saying here with the actual explicit explanations and different ways of cutting and different ways of showing things, and also a little bit of what it used here to pretty robustly provide this transcript here. And I'm also very impressed because all that it's doing is looking at the text. So it didn't know actually what's going on in the video outside of what's being said. So the fact that it is doing segments with recommended cuts and video things here is actually I'm impressed by what we've got here. Also at the bottom here, I just have a quick disclaimer. Always got to add one of those when working with these artificial intelligence models. So that is a that's a pretty fun transcript that I was able to take sort of from the video, analyze it, and then create one that's different on a topic of my choice. So I ran a couple more to see sort of the differences and try and find some of the limitations and the boundaries that this program would have. The first one that after that I tried out was using this Linus Tech Tips video.
Maxed out Mac Studio. When the HP Z2 Mini G9 is $1,000 cheaper, more compact. Oh, and did I mention it has a Core i9?
He's pretty much the master of writing these transcripts, right? And in this video, he explains the differences between sort of the Mac Mini or the Mac Studio here, and then this other HP one. And what I wanted to do with that is then, using sort of those techniques, compare and contrast plastic lawn chairs versus the ones that have a fabric weave in them. You know, the ones that are all out in the backyard. And what this sort of brought me to one of the interesting points of actually using this, is because it's much better suited for taking similar styles to similar topics of what you would want. So I chose this comparison video to explicitly talk about another comparison. And it's from its analysis, it says some pretty interesting stuff, sets up both of the products being compared, making it very clear, uses focuses on the price, size, performance, poses some rhetorical questions, talks about how, it's a very casual conversational tone, the transitions going here, mimics a natural conversation with sort of some of these things like, but wait, it's thermal throttling immediately and whatnot. Conclusion is straightforward, offers a very clear recommendation, summarizing, video's arguments effectively, a little summarization here at the end too. And then the new transcript here is pretty funny, I would say. It's like, why would anyone opt for the standard plastic lawn chair when you can get those with a fabric weave for just a bit more? They say comfort is king, and in the world of outdoor seating, this couldn't be truer. And, add some funny stuff here, like, here's the catch. Not as weather resistant as their plastic counterparts. It's not all doom and gloom for fabric weave chairs. They do have their advantages, especially in the comfort department. So it sort of is able to very effectively take how these videos are formatted, run a quick analysis on it, and then make something similar for a different topic. For the third example, I wanted to sort of test something out, because in this video, actually,
let's go. We only got 5 minutes left for this assignment.
Yeah, wait. I just got to safely remove my USB drive.
Snap out of it, man. It's 20.
It has a lot of different sort of skit elements, and as you can tell, 2 people talking at once. So I wanted to see if it will be able to sort of distinguish whether or not that this is actually like an ongoing conversation. And pulling up the report here, it actually was able to do that. The transcript presents a conversational exchange between 2 characters, focusing on the common technological misconception about safely removing USB drives. Picks up on some stuff like direct speech and colloquial language, with like, all right, man, snap out of it. Sets an informal tone, makes it approachable. Mentions specific sort of practical advice, incorporates a mini lesson about the feature of these things, yada yada. But what I wanted to do was then throw at something completely out of left field, innovative ways to bake blueberry muffins, and see sort of how it would take this, whether or not it could actually determine whether it's multiple people talking, and then how it's able to apply that to something not really super related. And it actually put together a conversation flow for me here for the new transcript. Things like, hey, did you know there's a new way to bake blueberry muffins that's totally changing the game? Wait, what? I thought muffin baking was pretty standard. What's this new method? All right, picture this. Instead of just mixing blueberries into the batter, you freeze them first. It's 2023, not 1993. This little trick keeps the berries from sinking to the bottom and turning your muffins into a soggy mess. Funnily enough, it's 2024, but these models don't know that. And yeah, so it was actually able to sort of put this conversational thing together for me with sort of adding those very colloquially easy flow conversationals, things about little tips and tricks about how to make your blueberry muffins better in sort of this style. So even with a little bit of that, still good to go. So all in all, I think this project actually was able to do what I was asking, what I was looking for it pretty effectively. I think some of my thoughts about it is that this really is an interesting sort of roundabout way of doing like prompt augmentation. Instead of taking one specific prompt and doing like a zero-shot input to try and get your output, I'm running it through a few steps to get that final output. Things like having the model actually look at what's inputted, and then instead of just me writing, create a script about audio interfaces, it will then augment that using the additional information that it itself generated with the analysis. So I thought that was really cool to sort of do this compounding sort of input into this final output to make it a lot more robust, a lot more exact on what I'm looking for. Few of the sort of limitations is, of course, it's very dependent on the actual videos that you're being put in being script heavy. So that's why I use things like Linus Tech Tips and David Bumbell, who tend to have very straightforward, scripted, very conversational heavy videos. This wouldn't be great for looking at something with, no audio, no text, and no speaking, things like that. Of course, also, there's plenty of different models out there that would be wonderful to test with and see sort of the differing outputs. But for this sort of experiment, it was really cool to see that it was able to very effectively take a lot of these ideas, run a pretty robust analysis, and then using it all generate something completely new in a similar style. Maybe I'll even use it to create something funny and short myself. But thank you for watching, and hope this provided some ideas and spurred some innovation and inspiration in you. Thank you.